5.4, solving radical equations. Okay, how do we solve an equation when there are a radical, a square root, a cube root, something of that sort involved? Okay, so as we look at A, square root of x plus 5 minus 1 equals 3. I don't know. What do you think, Ian? And why am I moving over the 1? Okay. Okay. So, and how do I move over the 1? Since it's a minus 1, I'm going to add over. Okay. And by adding over that 1, what does my equation read now? Okay. Square root of x plus 5 is equal to 4. So what did I just do to that radical, that square root? I got it by itself. Okay. Step 1, isolate your radical. Is my radical isolated now? Yep, I have just, when I say isolate the radical, meaning I have the radical, so in this case the square root and whatever's underneath it by itself on that side. And now what? What do you think?
Square.
And why are we squaring it? Yeah, since it's a square root, I'm going to square it. If I square the left, we're going to square the right. Okay. What do you get when you square the square root of x plus 5?
X plus 5.
X plus 5. What do you get when you square 4? And I don't know. You guys think you're capable of finishing?
Oh.
Maybe. If it's x plus 5 equals 16, what are we doing?
Subtracting 5.
Subtracting 5. And what do we come up with?
X equals 11.
X equals 11. Okay. Now, before we move on to this problem, 1, we'll talk about steps here in a moment, but 2, you need to be in the habit, because we're working with square roots, of checking your answers. It doesn't have to be a written check, I don't require that, but you need to be in the habit of checking them at least mentally. Okay, now, on this first one, I'm going to write down a check just so you can see what I mean. What do I mean by checking? Plug it back in. Okay, so in this case, we're claiming the answer is 11. Let's check it and make sure it works. So the square root of x plus 5, what do we find x to be? 11. So square root of 11 plus 5 minus 1 equals 3. And again, you can mentally do this. That's perfectly fine. I'm all for the mental check. But does it check? 11 plus 5 is 16. The square root of 16 is 4. And 4 minus 1 is 3. Does it work? It does, doesn't it? Okay. Get in that habit. Okay. Get in that habit of checking. So, kind of your general rules. First rule is always going to be to isolate your radical. Okay? And right now, notice we're just solving with one radical, right? I haven't gotten to a section that has 2 radicals in it. I think that's not till the backside, probably more likely tomorrow. First job is to isolate the radical. Once you get the radical by itself, you're going to, what do we do in this case?
Subtract.
Well,
Square?
Yeah, we squared both sides, didn't we? Okay? So that's going to be your general kind of steps, rules that work all the way through. Okay, you ready for B? Cube root of x plus 2 equals 4. Where would you like to start?
Move the 2 over.
Okay, going to move the 2 over because we've got to work to isolate that radical. So when we subtract 2 over, we're going to have cube root of x. 2 minus 2 cancels. 4 minus 2 is 2. Now what?
Cube both sides.
Cube. Why would it be cube?
Because it's a cube.
Okay. So last time we said once you got the radical by itself, we squared it. The last time it was a square root, yes? This time it's a cube root. So once you get the cube root by itself, we're going to cube it. And if you cube the left, you're going to cube the right. What do you get when you cube the cube root of x? X, right? A cube and a cube root are going to cancel each other out. You get whatever's under the radical, so it's x. On the right, what do you get when you cube 2? 2 times 2 times 2 is 8. Okay, so one thing I want to add real quick. When I said square both sides earlier, realize, is it always going to be square? It could be square, it could be cube, it could be whatever power we needed it to be, okay? Now, before I move on B, what should I do? Check, okay? Mental check is fine. 8. Take 8, put it back in. The cube root of 8 is 2. Plus 2 is 4. Does that work? Yeah. Okay, that's a good one for a mental check, isn't it? Not too difficult. When it's a more difficult check, write it out. Okay, you ready for C? What are you doing? Square root of x minus 2 plus 3 equals 5. Someone give me a step.
Subtract 3 over.
Okay, we're going to subtract the 3 because I need to get that radical by itself. So now I have square root of x minus 2 equals 2. What's my next step?
Square.
Okay, the square root is by itself. So now we're going to square both sides. What's the square root of x minus 2 when you square it? X minus 2. On the right, 2 squared is 4. And to finish it off, if x minus 2 equals 4, then I'm going to add 2 and get 6. Does it work? Did you do a quick check? 6 minus 2 is 4. The square root of 4 is 2. 2 plus 3 is 5. It works. Okay. D. Cube root of x minus 1 equals 2. What's your first step? Cube. Can we do that right away? Yeah, the radical's already by itself, isn't it? It's already just the cube root on the left, so we're going to jump right into cubing. If I cube the left, cube the right. On the left, what happens when I cube that cube root? I'm going to get x minus 1. On the right, what is 2 to the third? 8. And if x minus 1 equals 8, then what do we know? Add 1 and x is 9. Okay, does it check? 9 minus 1 is 8. The cube root of 8 is 2. And that checks, okay? Those are easy to do a mental check, aren't they? That's why I'm all for it if mental check is good enough for you, okay? Now, in this scenario, we are one radical, and I'll be honest, I could have told you by looking that those answers were probably all going to work. The checks were going to kind of be just a process, and more than anything, I'm trying to get you in a good habit here. When you're working an equation with a square root symbol of any sort, I would be in the habit of checking. Okay? And it just really has to do with, more than anything, things like we can't take the square root of a negative. Okay? Those type of issues there. Now, on this bottom half, our check becomes very important because we're going to have some things that don't work sometimes. And this is where we talk about the concept of extraneous solutions. Have we talked about that this year?
Yeah.
We have? Okay. Okay. I kind of thought I'd introduce that word this year, but I couldn't remember. Too many classes. They all blur together. So, an extraneous solution is a solution that does not work when checked in the original equation. It's legitimately going to come up as an answer when we solve it, but it's not going to check. And it has to do with, in these cases, because there's an x outside of the radical, in addition to being underneath the radical, when we square both sides of the equation, we're going to create an extra solution. Okay? We run into that possibility at least. So, okay. Go with what you know, though. Square root of 3x minus 2 equals x minus 4. What's step 1?
Square root.
Okay. Square root is all right by itself, yes. So if the square root is all right by itself, we're going to go ahead and square both sides. Well, on the left, the square root of 3x minus 2 squared gives me what?
3x minus 2.
3x minus 2. What about on the right? What is x minus 4 squared?
X squared minus 8.
No.
Square plus 16.
16, yeah.
No.
Square plus 16.
X squared minus 8x minus 16. So that is supposed to be a 3 times 8 just carrying it.
Yes, but I think you had a math mistake in there.
3x minus 2 equals x squared plus 16.
It's not just x squared plus 16. What did you say, Emily?
I said x squared minus 8x minus 16.
Yeah, you have a small math mistake in there, but right idea. How did you get yours, Emily?
I did FOIL.
She did FOIL. Okay. So when we see x minus 4 squared, what's that really mean?
X minus 4 times x minus 4.
And how do we multiply x minus 4 times x minus 4? Do we get to just say x squared plus 16? No.
The middle.
We have to FOIL, so we missed that middle term. Those of you who said x squared plus 16, you were 2/3 of the way there. You just did FOIL, and so you're missing that middle term. Okay? And Emily just made a sign mistake. So I'm going to keep my 3x minus 2 on the left, and I'm going to FOIL. X times x is x squared. How many steps do I want to show here? Because officially, I don't know, do I need, so x times x is x squared, right? X times minus 4 is minus 4x. There's your outsides. Insides, minus 4 times x is minus 4x. And then minus 4 times minus 4 is plus 16. So if you clean that up, you have x squared minus 8x plus 16. So I have 3x minus 2 equals x squared minus 8x plus 16. Okay. Thoughts of how to solve next?
Move the 3x minus 2 over.
Okay. What do we do? By moving that 3x minus 2 over, we're making my equation equal to 0. And we're doing that because we see x squareds, x's, and numbers, right? So this looks like a quadratic. We're going to want to make our equation equal to 0. So I'm going to subtract 3x over, and I'm going to add 2 over. So now I have 0 equals x squared minus 8x and minus 3x is minus 11x plus 16 plus 2 is plus 18. What's our go-to method for solving this quadratic? We're going to hope and pray it factors, aren't we? Because we don't want to go the other routes. And they should be factoring today, folks. They really should. So we're going to factor this into two parentheses, we hope. X squared breaks into x times x. We need numbers that multiply to be 18 and add to be negative 11.
Negative 9, -2.
Minus 9, minus 2. 2. I said 2. My pen wrote something else. Okay. Am I done? What do we do? Yeah, set them both equal to 0, right? So x minus 9 equals 0. X minus 2 equals 0, which means we have answers of what? 2 and 9. Am I done?
No, check for extraneous solution.
Definitely should not be done in this scenario, folks. Okay? We're going to check. This can still be a mental check if you want. Now, here's what I'm going to tell you. You have to go back to the very original equation. You have to go back to an equation before you squared it, which is the original. Okay? I'm going to write out a check in this one. I don't have a whole lot of room, but I'm going to write out a check. Again, you don't have to. So I'm going to start by putting 9 in. Square root of 3 times 9 minus 2 equaling to 9 minus 4. So what do we have there? 27 minus 2, square root of 25 equaling 5. Does that one work?
Yeah.
Yeah. You end up with 5 equals 5. So that one's good. Okay. Repeat the process on the other one. Square root of 3, now I'm using 2, times 2 minus 2 equals 2 minus 4. Well, 3 times 2 is 6. 6 minus 2 is 4. Square root of 4 equal to negative 2. What's the catch here?
It don't work.
Doesn't work. A square root can never equal a negative. Because remember, a radical sign, when you have that radical sign in there, it's only indicating the positive answer. If it's going to indicate the negative answer, there's going to have to be a negative out there. And there wasn't a negative out there. Okay? So anytime you get a radical equaling to a negative, it doesn't work. Okay? So this doesn't work. The check fails, and guess what? Even though 2 appeared to be an answer, it's what we call extraneous. It doesn't work. Okay? Sorry, Part B, I kind of ran into you. Hopefully you guys did better. I don't know. Okay, questions on that one? You got the gist?
Do we have to include that 2 is extraneous in our answer?
On Savas?
Or like on your test and stuff, are you gonna want us to like write extraneous and like list them too?
So like on a quiz or a test for me, like something handwritten for me, what I would expect is, to me, 2 is magically there, or is naturally there, because 2 is part of our answers. I would expect to see 2 and 9 and just 2 crossed out. Okay? Unless I specifically ask, what is the extraneous solution, which normally you just see more of a problem like this solved. Okay? Now, I don't exactly remember what Savas does. Could Savas say, what is the extraneous solution? They could. Savas does some unique things at times. Okay? But to me, it's there because it's part of your work, but that's it. And again, you don't have to physically show the check. That's a personal choice. But I'm going to physically show it sometimes just to demonstrate. Okay, guys. What are you thinking on B?
Square.
Okay, the square root's already by itself, isn't it? So, jump right in and square. What is x when you square it?
Square.
What is that square root when you square it?
7 plus
7x plus 8. What's right underneath there? Okay. That was easy. Now what? Yeah, I'm seeing an x squared term, an x term, and a number term. I'm going to make this guy equal to 0. And, guys, if we're going to factor, isn't it just so much easier to have a positive x squared term to begin with? So that's why I make it happen. Okay? So I agree. I'm going to say subtract 7x, subtract 8. Yes, I know it's moving 2 terms, but I still think it's easier. So now you have x squared minus 7x minus 8 equals 0. And we're hoping this is going to factor. X squared we know will break into x times x. Can we multiply to get negative 8 and add to get negative 7?
Yeah. 8 and negative 1.
Okay.
Negative 8.
Yeah.
For factoring, I'm going with negative 8 and plus 1.
I wrote it down.
I was wondering if you were at the end.
I wrote it. Yeah, well, I went ahead and finished it.
Yeah. Okay. So minus 8 plus 1. Set each factor equal to 0. And that means I'm going to get answers of 8 and
Negative 1.
negative 1. Okay. Should I move on to the next problem?
No.
Nope. Now, I can tell you right now, without doing any work, one of these answers doesn't work. It's a very quick, easy thing for me to see. That's me. Okay. Let's check both of these real quick. If I put 8 in, 8 is equal to the square root of 7 times 8 plus 8. 56 plus 8, 64. Square root of 64 equal 8. 8's good. Negative 1. Negative 1 equals the square root of 7 times negative 1 plus 8. I don't have to go any farther, folks. What's wrong?
Negative.
A square root cannot equal a negative. It doesn't matter what this comes up to be. A square root cannot equal a negative. So as soon as I see that square root equaling a negative, that's my key to just stop there. Negative 1 does not work. Okay? So that's kind of a shortcut you can kind of beware and watch for. Okay. C, you ready? What do you want to do here?
Subtract the x, maybe?
And
Wait, would you add the 2 and then subtract the...
get the negative away.
Yeah, I don't know.
You just square all of them.
You can't square it yet. We still need that radical by itself.
Just do x.
Subtract the x over.
Subtract the x and the negative. Is that a negative 1 and put them in
It's a negative 1. Okay, so
So can you do negative x plus 1?
not exactly. So one option would be we could subtract the x over. And we have that negative 2, and then we'd have a minus x over with it. And then what we have out front is a negative 1. It's like a coefficient. It's multiplied by that radical. So You could leave it there and square it. It just becomes positive. You could divide it to the other side. Or my personal opinion is let's make that positive radical also. So I did a bunch of moving on mine, if I recall, in that I took the negative radical and moved it over here to make it a positive radical. You know, kind of like how I like my x squareds to be positive? Kind of that concept. And so I'm going to say, I'm going to leave the x here. I'm going to add the square root of x plus 2 over to the right. Now, if I do that, do I want this negative 2 here? No. I'm going to take the negative 2 and I'm going to add it to the other side. Is this the only way to do this problem? No way. Okay? Not at all. But the way I'm setting this up, we now have x plus 2 on the left. Oh, shoot. What am I doing? I'm jumping a step ahead. Okay. I have x plus 2 on the left, and I have square root of x plus 2 on the right. Got it? Radicals by itself. Now what?
Square.
We're going to square it. We're going to square both sides of the equation. What about x plus 2 squared on the left? You're going to have to FOIL, aren't you? We're going to have to do x plus 2 times x plus 2. Write that out if you need that FOIL reminder. So what are we going to get when we FOIL? X times x is x squared plus 2x, and then we have what? Plus 2x and plus 4. Or cleaned up is x squared plus 4x plus 4. Now, on the right, did you guys square the square root? What'd you get when you squared the square root? X plus 2. So I have x squared plus 4x plus 4 equals x plus 2. What would you like to do? Subtract the x and the 2 over to make our equation equal to 0. So now I have x squared plus 3x plus 2 equal to 0. X squared plus 3x plus 2 will factor x and x. Multiplying to be 2 is 2 and 1 that also add to be 3. So x plus 2 and x plus 1. And now we're going to set each of them equal to 0. And we get answers of okay. Go back into the original problem to try it, folks. Okay, I cannot stress that enough. Go into the original. So if I do a check here, if I use negative 2 minus the square root of negative 2 plus 2 equals negative 2. That's a lot of 2's, folks. Negative 2 minus 0 equals negative 2. Does it work? Okay, negative 2 works. Check negative 1. Negative 1 minus the square root, negative 1 plus 2 equaling negative 2. Negative 1 minus the square root of 1 equals negative 2. Oh, negative 1 minus 1, does that work? Yeah. Oh, so what just happened here? both worked, didn't they? Dang it, come on. I'm too close to the bottom here. Okay, they both worked. That happens sometimes. Okay, don't fall into that, oh, there's always going to be one works, one doesn't work. Don't fall into that. You can have both work. You can have neither work. Or you can have one and one. Okay? You get out of 11, right? Okay, so I guess I'm stopping there. I had planned to get to the back side, but that's all right. Tomorrow we'll plan to go through the back side.
Got you ready for this chem test?